ना झलकता हो। मेरे पेपर सारे बेकार हो जाएंगे ना। नेट चला गया क्या? ये आ गया।
Recording in progress.
आ गए क्या सर? मैंने इस कमरे में देखा था। दादी की नस चली गई, मेरी दादी के हाथ की नस चली गई, बहुत दुख रहा है, जोड़ा बिना बंदा, अब क्या होगा मेरा। और पता है नौटंकी में गई है, जब उनके कपड़े बोलो बादल की नस से उनकी पेटी को सुखा दिया, तो भी उन्हें झाड़ के सुखा रखा, उन्होंने ऐसे झाड़ा और ऐसे डाला। और ज्यादा जब तक ले जाएंगे ना जब तक बहुत दर्द नहीं होगा, दर्द मामला नहीं होगा, दर्द है तो दिखा लो। पहले डॉक्टर को नस वस बना हट गई, नस वस ये दर्द थे बुद्ध वाला बुद्ध ही लगाया, क्या बता नहीं इन्होंने संदूक पे रख के प्रेस कराए, संदूक पे रख के कौन प्रेस, तो फर्श तो नीचे आ गई है, लकड़ी पे रखते हैं। जिंदगी याद तो रहेगा, देखने वाला क्या रात को आते हैं भैया को बुला लेगा तो वो जल्दी उठ जाएगा ना। भाई तो बहने फिर उन्हें संडे को सैटरडे संडे को लगता होगा कि हम यहाँ क्यों हैं। लगता है मैं तो ये कह रही हूँ, सच में कह रही हूँ, यूनिवर्सिटी वाला आपने वो करा रहे जितना किराया खर्चा जाता हो उतना तो 2000 जाते मिल जाता है तो अब पैसे सर आ गए क्या, रात भर मेरे भी सर में दर्द हुआ है, दिख रही है। मैं सही करवा सभी का आग्रह था। और वो वाली लाइन नीचे बढ़नी थी, शिक्षकों वाली जो यहाँ बढ़ा दी, विभाग के सभी शिक्षकों के समय समय पर सुझाव मिलते रहे। वहाँ पे नहीं, वो तो मैंने पेज काटा नहीं था ना तब तक, समझ में नहीं आ रहा था ना, इसलिए नहीं काटा। कहाँ सो रहे थे वो? क्या कहा उन्होंने? प्रेस विज्ञप्ति सब वही चेक करते रहे करें। यार अब तो उन्हें आना नहीं चाहिए, उन्होंने बता तो दिया है, सर गाइड करेंगे, तो वहाँ जाती नहीं है। लिया ना क्यों आज की तो पढ़ लिए वो खा के आया ये पेपर ज्यादा अच्छा चला गया खा के आया वो चल तो फिर कोई बात नहीं तो फिर वो स्कैन वाला काम हो गया साइन जो दिए थे पेपर का प्रैक्टिकल पेपर शुरू था फाइनल बच्चे क्या बनाया ड्राइंग में ये होता है ड्राइंग क्या बनाया प्लान का पेपर होता है वो स्तूपा पर कौन कौन से स्तूपा था स्तूपा और क्या कहते हैं अरे फाइन आर्ट बोलना फिर फाइन आर्ट ड्राइंग में साथी तो खाता है वो तो और भी इजी है सर्कल बना दो आप फाइन आर्ट सबसे बड़ी बात एजुकेटेड है ना गवर्नमेंट तो ही रहेगा भैया सबसे पहले तो वायरिंग को रूटिंग कराओ, वो सारी गेट पे रखी पड़ी हुई है और बिल्कुल वहाँ पे आपका ये जो है जहाँ पे वो लग रही है आपकी एमसीबी, वहाँ पे सारी वायरिंग करा रखी है, निकलने बढ़ने में बहुत दिक्कत हो रही है वहाँ पर मुझे। वो सही नहीं करके गया, वो सही नहीं करके गया, वो ऐसे ही चला के चला गया सारा सामान। उस दिन भी आया था वो शाम को, लेकिन फिर दोबारा चला गया और 2 दिन फिर आया था। मैं उस दिन घर पर नहीं था, बात सारी है कि अगर मैं मना कर देता फिर तो ये कहते कि कंपनी को अलाउ नहीं कर रहे हो आप घर में एक्सेस, फिर दिक्कत आ जाती। सारे का सारा जो इलेक्ट्रिसिटी का वायर है जो पोल पे से आ रहा है ना, वो एमसीबी के चारों ओर लपेट के चला गया, बाकी गेट पे लटका के चला गया। इवन गेट भी अगर खोलने की कोशिश करोगे तो अंदर की तरफ खुलेगा नहीं, इतना नीचे रखेगा है। हम्म, हाँ, मीटर बाहर लगाया है उसने और पुराने वाला मीटर लेके गए, उसकी रीडिंग भी नहीं लेके गए वो। मैंने नहीं, इन्होंने पहले ड्रिलिंग रीडिंग तो सब करी है इन्होंने, उसमें रीडिंग तो है उसमें। मैं वही तो कह रहा हूँ, पीछे से वो सारा काम करे चला गया। उसने मैंने कहा कि भाई मुझे उसका स्क्रीन शॉट तो सेंड कर दे, क्योंकि इन्होंने स्क्रीन शॉट मांगा जो तुम्हारा मैनेजर है, अब वो स्क्रीन शॉट भी नहीं सेंड कर रहा। कैसे डील करो, मैं फिर कंप्लेंट करूँ क्या कहीं? हाँ, नंबर है मेरे पास, नंबर है मेरे पास। मे, मेरे पास है नंबर, नहीं मैं उसी की करूँगा ना, जो वो बंदा था मैं उसे फोन नंबर शेयर कर दूंगा उसका। चलो मैं, हाँ, नंबर सेंड कर रहा हूँ फिर। हाँ, लड़के भी छोड़ते हैं ऊपर रैलिंग पे बांध दिया वगैरह, कोई करंट के तार को रैलिंग पे बांधता है, किसी को बच्चे बच्चे ऊपर रहते हैं करंट लग गया फिर क्या करेगा वो? मैं उससे उस दिन कह रहा था। हाँ, हाँ, टावर पे नहीं, जो पोल से आया है ना वायर, पावर सप्लाई जो मीटर में आ रही है उसे उसने ना रैलिंग से बांध दिया ऊपर डायरेक्ट। वो भी इवन कोई रस्सी से बांध दे तो फिर भी अलग से डिस्टेंस हो जाता है, उसने रैलिंग से ही बांध दिया वो सीधा। हाँ, उसे लटका दो एटलीस्ट, कम से कम ऐसा तो कर दो कि भाई इलेक्ट्रिसिटी उसमें ना है, रैलिंग में ना है। तो चलो ठीक है, टाइम निकाल के ऐसे कर दो काम, ऐसा करो ना दिक्कत ना हो किसी को भी। तो उस दिन मैं घर पे नहीं था। बस मैं भी नहीं था, मैं भी इमरजेंसी में फंसा हुआ था। मैंने उसे बोला फोन करके कि भाई सही लगाइयो और ऐसे ऐसे लगाइयो, अपनी मर्जी से लगा के जाना है। चलो ठीक है, इसे करा दो कोई और हो, आप कर दो, आप भी तो टेक्नीशियन हो, इलेक्ट्रिसिटी का काम तो जानते हो। हाँ, नहीं मैं मीटर भी हटा दूंगा, मीटर लगने की ऐसी बात नहीं है, मीटर हटाने में सेकंड लगेगी मुझे, मैं ढाबा में लटका दूंगा जब भी तो कंपनी आएगी। नहीं, मैं बताता हूँ ना इसका क्या है, मैं बताता हूँ इसका क्या होगा। मेरे पास उसका नंबर है जो यहाँ पे वो है, क्या बोलते हैं बिजली वाले को, यही जो है यहाँ पे, मैं उसे फोन कर दूंगा। आप वहाँ पे अवेलेबल रहना, सारी वायरिंग कराना जैसे करानी है, ठीक है? वो लाइन मैन को भेज देगा वो। ठीक है, लाइन मैन को भेज। एक कंपनी का था, एक बिजली का था, दोनों। उसका नंबर सेंड करता हूँ। हाँ मैं उसे नंबर भेज रहा हूँ आपको, आपसे बात। हाँ ऐसे बोलते हैं ना, हाँ ऐसे बोलते हैं। ठीक है, ठीक है।
Hello, am I audible? Please respond in the chat box if I am audible. Thank you.
Yes, sir.
Third session of the fourth day of the workshop, that is Vedic Mathematics workshop from 22 to 28th of August 2022. So the next session is the title of the talk is Introduction of Trigonometry from Ancient Mathematics, and our speaker is Dr. Prajakati Ghokhle ma'am from Pune. And I would like to say about the session. This session will be chaired by Dr. Rajesh Thakur sir, and the introduction of Prajakati Ghokhle, I can say she is a visiting faculty in the Symbiosis School of Economics, teaching for BSc honors students, subjects including stats and operation research, and MSc students teaching experimental designs and research methodology, ma'am. Are you hearing, ma'am? Are you? Yes. Welcome to the workshop, ma'am. Thanks for coming. I'm just introducing to you.
Thank you, madam.
Thank you. So she is a visiting faculty in Gokhale Institute of Politics and Economics, Pune, teaching stats for first year BSc students. Honorary director of IAVM. It is an NGO working in popularization of Vedic and ancient mathematics in the world. She is also a volunteer for NGO Asim Foundation, working in border areas like Kashmir, Ladakh, and eastern states, conducting educational projects like astrotourism, teacher training, NDA entrance training for students and teacher in this region. She has conducted many Vedic mathematics workshops for students and teachers also all across India and abroad. Her research area is Vedic mathematics and economics also. She has presented many research papers and virtual presentation regarding creative recognition of mathematics textbooks in India in International Symposium in Tampere, Finland, November 2015, organized by CCE, means Council for Creative Education Finland. She has presented the paper on innovation in teaching and learning for the future, sustainable quality education, case studies for Maharashtra, organized by MNIT Jaipur and Indian Economic Society, September 2020. She has also presented and conducted a session on Leelavati, aesthetic perspective of mathematics and creative pedagogy based on the research of ancient mathematical text in virtual International Vedic Mathematics Conference conducted in June 2021. So now I welcome to Dr. Prajakati Ghokhle ma'am from Pune. Now ma'am, please, we are very thankful that you join this workshop as a speaker. So now I would like to invite you. Please, ma'am. You can start your presentation.
Thank you. Dipti madam, I have time till 4 o'clock, right?
I'm Dr. Sonia. Actually, her laptop is running here. So,
okay.
Yes.
So till 4 o'clock, I have time, right?
You can conclude at 4 p.m.
Okay. Okay.
So you have enough time to represent yourself, ma'am. Thank you.
Thank you. Thank you. So now, thank you everyone. And it's really very nice to attend this workshop. And of course, being a speaker here is a very great opportunity. And thank you for CCSU for giving this opportunity. So I know that in last 3 days, lot of things have been talked about ancient maths, about Vedic mathematics. So even my topic, trigonometry, was discussed yesterday by Sir, one of the speaker, and Budhayan number. So I'm just extending more applications of it. So since it is a workshop, it is, I hope that there are many students also who are joining. So I will share my screen and...
Before starting your presentation, ma'am, I would like to invite Dr. Rajesh Thakur to say something about this session.
Yes. Dr. Rajesh Thakur, please, you can just brief about this one. Thank you, sir.
Good afternoon, ma'am. Okay. Your topic is a trigonometry from the ancient mathematics. So I do hope that you will be talking about Surya Siddhanta and some of the contribution made by the Aryabhatta and Brahmagupta in the recent past. Moving into the 14th century, and I can see the portrait of Madhava Acharya in the auditorium. So I do hope that you will just be highlighting some of the core issues Madhava and the Nilakantha Somaiya have carried forward the legacy of trigonometry. So thank you, ma'am. I do hope also enjoying some of the content you will be delivering about the ancient mathematics related to basically trigonometry. So thank you very much, ma'am.
Thank you.
Thank you, sir. Now you can start your presentation, ma'am. Thank you.
Thank you. Yes. So now, although it is about trigonometry and ancient maths, I will be, rather than talking only introductory things, I am going to explore or see the applications also. And basically it is a triple algebra which we called. So trigonometric applications. So in this particular presentation, there are two presentations. In the first presentation, I am going to talk about the introduction. And in the second presentation, we are going to see actual trigonometric problems and how our perception of trigonometric problems can be actually changed with the help of triple algebra or triple or Bodhayan numbers, which yesterday we have seen. So let us proceed further. So now this is the today's session. So I will be giving you historical perspective. Then let us see the timeline, various texts which actually already discussed in this workshop. So I'm not going to put more emphasis on this. Of course, important trigonometric formulae which appeared in various texts, and of course, introduction of what exactly triples are, which we call nowadays, although it is called as a Pythagorean triples, we can also call it as a Bodhayan triples, and how to generate them, how to construct them, what are the types, whether they have got families, like the number, like coprime numbers, whether they have got any types of unique characteristics. So this is the thing which we are going to see. So now let us discuss. So in between, if I ask some questions or any examples, please feel free to write it in the chat box. So now let us see, please observe these numbers. So I'm going to start with the question itself. So these are certain numbers which will appear in front of you. So I just want to know, what can you say about these numbers? Do you have any idea what are these numbers? So please feel free to type in the chat box. So basically these numbers are actually, we call them as a Ramanujan numbers. And what are these numbers? So they are showing a peculiar properties of a cube plus b cube equal to that number. So here actually we can see these numbers as a sum of two cube numbers. Now again, here the question I always ask students, whether it is possible to get a numbers a, b, c, where you will get a cube plus b cube equal to c cube. So if there are any students here, they can see whether it is possible to get such any pair of natural numbers. Yes, all of you know these are Ramanujan numbers. I can see the answers typed by. So then let's proceed further. So I always ask question whether it is possible that you can have pair of triple of three numbers a, b, c, where a cube plus b cube equal to c cube. So of course we know that answer, and we will again discuss that at the end of the session. Okay. So we have to keep that in mind. So Ramanujan has discovered these peculiar numbers. So let's proceed further. So this is the timeline which we have seen in earlier lectures also. So today we are going to see about the triple or the trigonometry discussed by Bodhayana, Apastamba, in Shalva Sutra, in different texts, and we will see some formulas of trigonometry appearing at different times in different texts. So initially we see that, and of course we start with Shalva Sutra, which is a very early reference which we can see where we can find triples, and these are the formulas. For example, Brahmagupta's sine formula is, as we know that the entire sine table can be summarized in this simple formula. So if I say that I want to take sine 0, then sine 0 is root of 0 upon 4, which is 0. Sine 30 is root of 1 upon 4. Therefore, we get sine 30 as half. Then I take sine 45, which is third number 4, that is 1 upon root 2. Then we take sine 60, which is 3 upon 4, which is root 3 by 2. And finally sine 90, which is 4 upon 4, which is 1. So instead of remembering the entire table, which students used to do in 10th standard or 11th standard, they can directly only remember this formula and they don't have to remember the entire table. Such a simple formula, 0, 1, 2, 3, 4 upon 4. Comma indicates there, these are the consecutive values they have to take for the consecutive angles. So 0, first value, 30, second value, like that. And of course, denominator is separated for every number. So such a precise and wonderful formula we get, which is such a old actually. So therefore, similarly, we can see the trigonometric relation appearing in Varaha Mihir's text as well as Brahmagupta's text, sine rule and fundamental identities. And Bhaskaracharya talks about compound angles, sine of a compound angle or an addition of angle. I know that Bhaskaracharya talks about it, although it is already talked about in Shalva Sutra, where now today we are going to see by simple triple algebra how we can obtain compound angles, how we can obtain difference angles, how we can obtain several double angles. So we are going to do that today, and also we are going to solve some examples for that. So now let's proceed further. Similarly, there is another formulas to find out the sine of any angle. So we have seen the sine of typical angles, which are always useful for us. Now we are going to see the formula where sine of any angle, if I want to find, then what is the formula? So the Bhaskara has given this formula. Sine theta is equal to 4 theta into 180 minus theta, 40,500. Now, of course, here the proof is not given. You can substitute in place of theta for whichever angle you have to find the sine of that angle. You just substitute theta equal to that measure and you will get the value of the sine. So therefore, this is the comparison between actual value obtained by modern method and the value obtained by using Bhaskara's method. So you can see that there is a very less error in the values. We can always use these values for our calculation. So these are the ways they require to basically for writing different astronomical text, they require these values to calculate, and that's why they have developed various formulas at various times. So let's proceed further. So as we can go to Shalva Sutra, we know that this has been discussed in earlier sessions of this workshop as well, that this is a Shena Chiti and it has got a precise dimensions, how many, and it is always measured in Angushta, the unit, and how many bricks is required, how many levels are required, and exact calculation should be there to create this particular attire for yajna or for doing offerings to fire god. And therefore, this is a particular type of construction which is not very easy to do unless you have the knowledge of geometry. So similarly, we can see that there are many different complex altars are there. Now, this is a particular Ratha Chakra Chiti, which is of the round shape, Kurma Chiti, which is of the Kachua, or we call it as turtle shape. And all this has a very precise number of layers also and number of bricks also. So therefore, this tells us that Shalva Sutra was developed along with the different technology of doing or performing yajnas. And therefore, whatever the technology required to prepare the yajna kunda is developed in the Shalva Sutras. And that's why that entire geometry and trigonometry, we can see that it is appearing in Shalva Sutras. So therefore, we can see that this is the earliest text and it requirement of orientation area for different religious purposes. That ancient Mayas also used variation of triples in long count calendar. I think in this particular workshop only, I have seen that some calendar mathematics was there, and it was also Mayan civilization regarding that also it was discussed. So now this is the Budhayana. Now we call Pythagoras Budhayan theorem. All of us know this. I don't have to explain this. And therefore, what are triples? Then let us come to triples. So the triples kya hai? So let us see what are the meaning of triples. So it is just like a set of three numbers basically, which are sum of the squares of the first two number equal to the third number. So any such set of number is known as triple. So like this, I can create a triple. If I 3, 4, 5 is a one triple, I know that 3 square plus 4 square equal to 5 square. Similarly, I can divide 3, 4, 5 by 2 and I get another triple, and that can also obey the same rule. So triple in which all three parts are rational numbers are called as a perfect triple. So that is whole numbers or fraction or positive. Then triples naturally imply its presence. So we know that how to interpret triple. So this we have seen that any triple which I write, suppose I write the triple as 3, 4, 5. 3 is always my base. So the first number is always base. Second number is always not. So this is some of the examples. Out of them, some of them are triples, some of them are not. So I just want to know which one is the triples and which one are not. So if you can just write the answers, please write it. Out of them, how many are triples and how many are not triples? You can just write the numbers in the chat box. Then these are triples and these are non-triples. Already some answers are coming. That's great. Yes. Okay, 9, 40, 42 is not. Shipra, yes. First, second, third are triples. Okay. Okay, let us see. So first one is yes, it is a triple. Second is not a triple. Then third one is yes. Fourth one is also triple. Ninth one is not a triple. And 2, 3, 4 is not triple. 3. We know 3, 4, 5 is a triple. So we can see that we know which are the triples. We can easily see. And generally I tell my students that you can just looking at the number, you can know that whether it is a triple or not. And the same triples are going to appear in your exam. So easily students can identify what can be the dimensions when the triple questions are there. Now see, just like we have different types of numbers like prime numbers, multiple numbers, perfect numbers. So same way in triples also, we can have equal triple. When we call it as a equal triple, if one triple is a fraction or multiple of other. So for example, we have seen this triple 4, 3, 5 or 3, 4, 5. So if I multiply each number by 2, then I get 8, 6, 10. And if I half each number, I get 2. So all these three can be considered as equal triples. So that means from one given triple, you can construct infinite number of equal triples. Triangles, these triples represent all have the same shape or the same angles. Of course, all of them are right angle triangles, but the measure of other two angles will be same for all equal triple. perfect triple, element of such triple are always whole numbers. So like therefore 5, 12, 13 is a perfect triple. Prime triple, no common factor other than 1. For example, 5, 12, 13 is also prime triple. 3, 4, 5 is also prime triple. For every family of equal triple, there is only one perfect triple. So these are some of the types of triple which we can see. And therefore, and also there is a complementary triples. Like if you just exchange the base and height, we know that the angles are complementary and hence the triple is called as a complementary triple. So 3, 4, 5 and 4, 3, 5 are complementary angles. So hence it is a complementary triple. So triple complementary to a given triple, we transpose it first to Paravarta Yojayata. So transpose and apply. So we apply this Vedic rule and we can get the complementary triple. So now see, we will just see which is the type. So 5, 12, 13, it is a prime triple. Second one, 9, 12, 15, it is a perfect triple. Now 12, 9, 15 is a perfect as well as complement to 9, 12, 15. Similarly, 7, 24, 25, prime triple, no common factor. 10, 24, 26, you can say that it is a perfect and multiple of 5, 12, 13. Okay. And 3.5, 12, 12.5 is a multiple of 3, 4, 5. So like this, we can create many triples. And therefore, construction, how to construct triples. Like, which is a major question sometime for teachers who are teaching higher standards, that how to take a unique triple so that my question will become difficult. So if the teacher knows how to construct triple, she will select the odd or very, say, a triple which is not appeared in any questions before. And if I want to construct a trigonometry question, I will use the triple which is little bit complicated and little bit difficult for students. So then if I know how to construct triple, it will be easy for me to construct questions which are having a little bit difficulty level. So therefore select any two numbers. So this method is very much applied everywhere to construct triple. So suppose I want to take any two numbers having difference more than 1. So if I construct, say a is equal to 3 and b is equal to 5, then I find the terms a square plus b square, 2ab and a square minus b square. And with this help of that, I can construct a triple 3 square plus 5 square, 2 into 5 into 3 and 25 minus 9. So therefore, I will get the triple 16, 30, 34. So therefore, this is the triple I will get with the help of any numbers. I can take any numbers value a and b, provided there should be a difference of more than 1 and I can construct triple. So this is the first method of construction of triple, widely used everywhere. So now you have to try to construct your own triples. Very easy. Okay. So you can construct your own triple using this rule. Take a and b, then take a square minus b square, 2ab, and of course a square plus b square is the largest number. So it will be always a hypotenuse. And 2ab and a square minus b square can be exchanged as a general triple and its complementary triple. So we can construct two triples given this particular way of knowing how to construct it. Okay. So now let's proceed further. Now second method is really, actually it is based on the sequence or the pattern. So now let us consider the fraction. Suppose I consider the fraction 1 by 3. Then I get the improper fraction as 4 upon 3. And the triple generated is 3, 4, 5. Second fraction is 2 by 5. Third fraction is, so I will take 12 by 15 is my improper fraction and the triple generated is 5, 12, 13. Next is 3 by 7, 4 by 9, 5 by 11 and I can get the corresponding improper fraction and its triple. So what will be the next number? 1, 2, 3, 4, 5. So next will be 6, 6 upon 13. And what will be this improper fraction? 84 upon 11. So my triple will be, 84 upon 13. And my triple will be 13, 84, 85. So this is the way I can go on till infinity. I can take this sequence, I can extend the sequence 7, 7 by 15. Then next will be 8, 8 by 17, 9, 9 by 19, and I can get the corresponding triple here. So 7, 7 by 15, so 105 plus 7, 112, so 15, 112, 113. So like this, I can create these triples and I can do this. Now there is only one family of triplet can be generated using this. That family is the family of triplet having diagonal just 1 unit greater than the height. So this is the particular family of triplet is generated by this method. So these are the two methods which I wanted to discuss. So like this, we can extend the series and we can construct our own triples. So now we are going to see the next particular. So this is about the introduction of triples. What are the triples? Now I am going to go for triple operations. I know whether you can, I just share my screen. So now we are going to go for triple operations. I hope the screen is visible. Yes, Akshika, you have created a triple. That's very good. Okay, so now let's see. So, of course, this is very interesting how we can create a triple algebra, how we can add triples. So, addition of triples. Since we have learned trigonometry in our curriculum in a different way. So, little bit we have to unlearn ourselves when we try to understand this method. So I have given the short form to this method as SAM method. So it will be very helpful for students to remember it. Now what is the meaning of SAM method? We are using the sutra vertically cross and we are using this operation ka sequence hai. This is a sequence of operation: subtract, add, multiply. So when I go to add two triples, now when I am adding two triples, remember I am going to generate a triple which is compound angle. So A is having one triple, B is having another triple. I will be generating a compound angle A plus B. And once I get the triple of A plus B, I can find all trigonometric ratios of that compound angle, which is very interesting. I don't have to remember the formula of sin A plus B or cos A plus B. Of course, so this is something very different and very interesting to know that how it becoming very simple. So let us see this. Now my A is the triple, X, Y and R. R is a hypotenuse. Another triple B is capital X, capital Y, capital R. Then when I say subtract, urdhva tiryak bhyam. So urdhva is X into X, Y into Y multiplication. And I will subtract first. So this is my subtraction. So I am going to subtract first this multiplication and this multiplication. So this is subtraction. So S is for subtraction. Urdhva ऊपर मल्टीप्लाई करो और सब्ट्रैक्ट करो. नेक्स्ट इज एड. सो जस्ट लाइक डिटर्मिनेंट वी एड x into y प्लस y into x. लेकिन डिटर्मिनेंट में हम पहले यहां से यहां लेते हैं. Here you have to take capital X into small y. So since it is addition, it will not make any difference. But when we are doing subtraction, that time I will tell you which is to be taken first. So ye just like determinant, you have to crisscross or vertically. So urdhva tiryak bhyam. So it is a tiryak. So crosswise multiplication and add. So this is addition. And finally multiply hypotenuse. So this is a simple way of construction A plus B. So now let us take example. So A is a triple 4, 3 and 5. B is a triple 15, 8 and 17. So now let us use the SAM method, SAM, SAM method. So let us use the SAM method. So subtract, add, multiply. So 60 minus 24 gives me 36. 32 plus 45 gives me 77 and 85. So therefore 36, 77, 85 will give me compound angle triple. Now imagine that this is your compound angle A plus B, जिसका base है 36, height है 77. So height is actually responsible for sine ratio. Base is responsible for cos because adjacent upon hypotenuse, and this is hypotenuse. So therefore, if I want to find the sine A plus B, tell me what will be my sine A plus B and tell me what is my cos A plus B. Write it in the chat box. What will be my sine A plus B and how? Yes. So tell me what is sine A plus B. Yes, this Divya. Sine A plus B will be correct. It will be 77. Correct, Divya. 77 upon 85. And cos A plus B will be, of course, 36 upon 85. One side, no sine and cos, everything can be known instantly, right? So therefore, this is, let us proceed further. Now, how I will see this particular diagram. So addition of triples, so it is like superimposition of one angle on another, and therefore this is the super angle A plus B with bigger triangle. This is the way I can imagine. See, in our curriculum, we just do find cos, sine, compound angles, addition, subtraction, but nobody told us how to imagine कि जब A और B हम ऐड करते हैं तो हमारा ट्राइंगल कैसा दिखता है, हमारा सुपर इम्पोजिशन एक के ऊपर कैसा होता है. So we should understand it conceptually, right? That how it looks. So it looks this way. So this is the way we do it, and we create this big angle whose trigonometric ratios can be easily obtained with the help of triple addition. Okay. So now let's proceed further. So the list A and B, then addition of A plus B is compound angle. Diagrammatically, we can see like this. Yes. Okay. Yes. Akshika, you have also answered yes, 77 upon 85. Okay. So let's proceed further. So diagrammatic, so now जो सूत्रा हमने सीखा vertically crosswise. So generally we call diagrammatically we do this way, SAM method. We add, multiply and add, then vertically multiply and urdhva and subtract, vertically multiply and add, and then finally multiply. Okay, so now let us see this triple addition. Another example. So 4, 3, 5, 24, 7, 25. So now how we will get? So we get this, suppose I am adding these two triples, 96 minus 21, 28 plus 72, and finally, but now I obtained this triple, 75, 100, 125. You can see that I can take 25 common and I get the triple. I can divide it and reduce the triple into 3, 4, 5. So this can be also done. You can reduce it. But as we know diagrammatically, this is a superimposition. So this will be the bigger triangle. Now this is something for you. Okay. So you are going to add it. So I think we need practice here. So please write down in the chat box what is your answers of these triples. You are going to use the SAM method. So SAM is a very nice way to remember. Subtract, add, multiply vertically crosswise. So this is our sutra. Urdhva-tiryakbhyam. So we are going to obtain A plus B here, P plus Q here, and C plus D here. It can become some triples, you may get negative also. So some answers have already started coming. That's good. Shipra, yes. Divya, you have started answering. So this is 96 minus 75. So first will be 21, 220, 221. Yes, that's the correct one. First one. Second one will be, yes, second one, let us see whether it is correct. 12 times 24. Sorry, this is subtraction. And finally, so this is the another triple and this is simple. So this is, I think it is 253, then 304, 320. And this one. So I have actually solved them. See, solution 1, 21, 220, 221. Okay, I can see that. Yes, yes, yes. Minus is also coming somewhere. Yes. Then solution 2, let us see the solution 2. So it is 253, 204, 325 and solution 3 minus 133, 156 and 205. And most of you have solved it. I have seen that in the chat box. So this is the way once we obtained. Now here we can do this. Now see A plus B, this is my base, right? So I'm getting the base negative. So that means my cos is getting negative. And my height, that is sine, is getting positive. So therefore, if my cos is negative, can anyone tell me which is this, in which quadrant this particular angle is going? So all silver teacups, right? So which is the quadrant in which I can find this angle? Just type it. I know I'm asking these questions, but I really need answers because that is really interesting how we can explore trigonometry just with the help of triple addition, right? So therefore cos is negative, so it has to be the fourth quadrant. Yes. Yes, Divya madam, absolutely. So this goes in the fourth quadrant. So we can see that it is very much applicable. So now let's go to the next one. So triple, now similarly, just like the compound angle, we can go for double angles, right? So therefore now, how to create a double angle? It is just the same angle superimposed. So we get the double angle. We have various trigonometric formula. Remembering them, it's a very big trauma. I know it in 11th standard. So now what we do, it is just ax, y, z and the same one AXYR. So if I add them, of course, it will become 2A. And of course, we have this SAM method. So subtract and therefore x square minus y square, xy plus xy, 2xy and r square. So we can just use this formula x square minus y square, 2xy and r square to obtain the double angle, 2A. So now let us see the double angle. So see 12, 5, 13, 12, 5, 13. So therefore we get 144 minus 25, then 60 times double of that 120 and 169. So we get this 119, 120, 169. So now therefore what is my cos 2A? And what is my sine 2A? So cos 2A, sine 2A, and finally tan 2A. So we don't have to use the formula. Suppose I want tan 2A. Tell me what is the answer of tan 2A. Very simple. So double angle can be obtained very easily. So tan 2A will be 120 upon 9, right? And therefore, double angles also can be obtained very easily. Yeah. Now let us go to the next slide. Oh, this is something for you. Now let us find the double angles. Come on. We are going to find the double angles. I will write the formula here. So what was the formula we have learned right now? So it was xyr. So x square minus y square, SAM method, then 2xy and r square, right? So you can obtain the triple of double angle of 2A, 2B, 2C, 2P and 2R, and all corresponding double angle trigonometric ratios we can obtain very easily. So therefore this is 16 minus 9, 7, 2xy, 24, 25, right? Then 225 minus 64, so that will give me then 240, 289. Like this, I will get the double angle for each of this. Oh, sorry, 209 it was. I made the calculation mistake. Okay. Okay, so let us see these answers. So therefore, these are the answers of all the double angles which we are getting. So 2C, 2A, 2B, 2C, and now we can find out its so suppose I want to find the trigonometric ratio, say for this one, 2C. So what is my cos 2C? Anyone can write it in the chat box. What is cos 2C? B answer is wrong. Oh, yes. So this 209 looks wrong. Okay, so let us see cos 2C. What is cos 2C? What is cos 2C? Yes, very good. Shipra, you have given the answer. So it is 41 upon 841 will be cos 2c. Similarly, you can see that here 2p and 2r minus 119 and minus 161. So again, cos is negative. So these double angles will go in the fourth quadrant. So see, without using any compound angle formulas, we can get the double angles and we can also get the addition of angles. So let us proceed further. So now we are going to go for next part. Now, just like subtraction, just like addition now, we are going to go for the subtraction of triple. So now this is, I will call it as ASM method, which is exactly opposite of SAM method. So now, of course, as I told you, we have not learned this anytime in our career of mathematics. So when we are learning this for the first time, we do a lot of calculation mistakes, and therefore we have to do it very carefully. But once we get there, we can solve complex trigonometric problems with the help of triples very easily, and it boosts confidence, and also it is very interesting. So now let us find the subtraction of angle. So here we have to add first. So urdhva is the addition, xx and yy. Then, as I told you, we are not going to use determinant style, but it is like x into small y. So this will be yx minus xy. So from right to left, this diagonal you have to take first, and then you have to take the another diagonal. So this is different than the determinant. In determinant, generally we take this diagonal first minus this diagonal. Here you are going to do the reverse way. You take first another diagonal and then xy, and then finally r into r. So here we are going to use subtraction of angles. So let us see the subtraction of triples a minus b. So I have selected these triples. Example 4, 3, 5, 15, 8, 17. So as the first thing says add, we will add urdhva, that is upward multiplication. So 60 plus 24, 84. Then as I told you, first you take this diagonal. So 45 minus 32, which will give me 13, and finally 85. So this is the subtraction of triple. 84, 13, 85 is the angle which I obtained by subtracting a minus b. Now I am giving you some practice. So this is a ASM method. So ASM method, add, subtract and multiply. So now I just want you to try this to find out a minus p minus q and c minus d. Okay, so let's evaluate this. I know answers have started coming, so that's good. Very good. So many answers. Yes. Yes, Shubham, Raj, Reva, Shagun, or most of you have given answers. Very good. Harshit, Chandra, yes. Thank you. So we can discuss these answers Okay. So let's see the answers of this. I have not taken. So first one, we can evaluate these answers. So A minus B. So add, subtract, multiply. So therefore 21 plus 96. Then subtract. So as I said, 72 minus 28 and 125. So therefore this will be the first triplet. 117, 6, 4 and 44 and 125, right? So I can see this answer is there in the chat box. 117, 44, 125. Shubham, you have given that answer. Next one is P minus Q. So it is 48 plus 15. Then 36 minus 20 and 65. So therefore we will get 63, 16, 65. And next 36 plus 20, then 15 minus 48 and 65. So here it is 56 minus 33 and 65. So now see, this is C minus D. Which trigonometric ratio is negative? This is base, means cos. This is height, is sine. So therefore, which trigonometric ratio is negative? Sine is negative. So therefore, which quadrant it will go? C minus D will go in which quadrant? We can see that. So cos C minus D will be 56 upon 65 and sin C minus D is going to be minus 33 upon 65. So therefore, it will go in the, yes, second quadrant, correct. Shubham, yes, Richa, all of you. Yes, so it will automatically, we can understand that it will go in the second quadrant and all others are remaining in the first quadrant. So see, you can always imagine that then where this can go, how this may be looking at, how it will look. So like this, we can do it. Now let us see special angles which we are always interested, whether we can find the triples of the quadrant angles, and if we can find them, how we can interpret it. So see, we know that 90 has a 10 coordinate. So we always have a triple 101 associated with 0 degree. For 90 degree, we will have a coordinate 01 in a unit circle. So the triple associated with 90 degree is 011. Similarly, triple associated with 180 degree is minus 101. Triple associated with 270 degree is 0 minus 11. So these are the standard triples. If we remember them, we can find out the angles which are A plus 90 or pi by 2 plus theta, 3 pi by 2 plus theta, 2 pi by theta. So all such type of quadrant angles we can find out and we can work on this. So here are the some examples for you. Of course, I am going to discuss it, but you can take the screenshot of this and we will be solving this example with the help of triple algebra which we have learned. Okay. So suppose I want to find out the trigonometric ratio of 75 degrees. How I am going to do it? I want to find, with the help of triple, I want to find, so I can split 75, of course, into two parts for which I already know the triples of those two angles. And then with the help of a triple addition, I can always find out triple of 75. So let us see what is the triple of 75, right? So triple of 75, I can always do 30 and 45. Now, how to find the triple of 30 degree? Okay, so I will tell you how to find. Suppose this is my right angle triangle with my A is 30 degree, right? So my A is 30 degree. Of course, this will be 60 degree. Now, suppose my hypotenuse is 1, then my side opposite to 30 will be half and my side opposite to 60 will be root 3 upon 2. Now, I don't want this in fraction and I multiply everything by 2, then what I will get? If I multiply everything with 2, I will get base equal to multiplying by 2, I will get hypotenuse as root 3, 1 and 2. This can be my triple of 30. Similarly, I can have the triple of 45. How to construct a triple of 45? So 45 degrees, I have this B 45. So this is equal and therefore I will have, if this is 1, then this is 1 by root 2, 1 by root 2. I have to multiply it with by root 2. So then I will get 1, 1 and root 2. So my triple of 45 will be 1, 1 root 2. My triple of 30 will be root 3, 1, 2 and I can add them. See, so 30 degree triple is root 3, 1 and 2. Similarly, 45 degree triple is 1, 1 root 2. And now I can add 30 plus 45 and I can add the triple to obtain. Now I have to do this compound angle A. So urdhva root 3, multiplication of these two, subtraction root 3 minus 1, crosswise addition root 3 plus 1 and 2 root 2. So therefore, what is my cos 75 degrees now? Can anyone tell me? And what is my sin 75? So I just have to obtain the triples and by triple addition, I can obtain 75 degrees and all trigonometric ratios of this. So therefore, base is root 3 minus 1. So I hope that you must have understood this, how I have obtained it. And so you have understood what is cos 75. So what is cos 75? Of course, it is root 3 minus 1 upon 2 root 2 and 75 root 3 plus 1 upon 2 root 2. So like this, I can trigonometric ratios without any remembering formulas, substituting, doing operations. So great. So you have answered it. Okay. So let's proceed further. So we have next question, which was actually so it was a subtract 12, 5, 13 from the triple of 45 degrees. So let us see that. Subtract 12, 5, 13. Now what is the triple of 45 degree? We have just seen it is 1, 1 root 2 and 12, 5, 13. So subtract 12, 5, 13 from triple. So that is 45 minus A. We have to obtain. So now we can do the triple subtraction we have to do. So we have to be using ASM method because we are doing subtraction. So addition, so 12 plus 5, 17, 12 minus 5, so 12 minus 5 and finally 13 root 2. So therefore I have obtained all trigonometric ratios of 45 minus A in this question. Okay, so this was my second question. Now let us go to the next one. Given 3, 4, 5, find triple of 270 plus A. So now I have to find the quadrant angles and all trigonometric ratios of 270 plus A, where A is given to you as 3, 4, 5. Now 270 degrees, as we know that it is like a 390 degrees or third quadrant where it finishes. So we have 0 minus 1 1 as a triplet form, and now we have to find the triple addition. So again we will use the SAM method. So 0, and now this is minus 1, so therefore subtraction. So here you can see that this is 0 minus minus 4, because it is a subtraction, becomes plus 4, and then 0 minus 3, so this is minus 3. So therefore tell me whether this agrees with what our trigonometry says. Now this is which quadrant? This angle goes in which quadrant? What is positive? What is negative? So here this is responsible for, so this is base, so cos, minus 3 is responsible for sine, and this is my hypotenuse. So therefore what is sine 270 plus a here? Is minus 3 by 5. So which is the quadrant? This will go actually this should come, yes. So this is coming in the fourth hona chahiye. But it is getting 7 in negative. So it is giving actually second. Yeah, so it is a bit confusing. It is giving second. Yes. So let us see whether we have done, if there is any mistake, we can see. No. Because originally it is, yeah. Okay, so let's proceed further. Now let us go to next question. Find the triple of 45 minus a. So now 45 is 1 1 root 2 and a is 5 12 30. So I want you to give that answer. I will wait. So you have to find out the triple of 45 minus a. So please type your answer in the chat box. So we want to do 45 minus a. So again ASM method. So let's use ASM method. There. Okay. Yes. Let us see that. 17. Yes, correct. So 17 minus 7 and 13 root 2. So therefore this is 45 minus a. So this depends on a angle. We don't know exactly. So therefore what is the measure of a angle? Accordingly that quadrant will be there. So this is cos, this is sine. So here also it is going in the second quadrant. Minus 7 upon 13 root 2 will be sine 45 plus a. So probably because of, so a will be, so therefore a angle will be such that it is going 45 plus a will be more than 90. So a must be more than 45 degrees. So therefore it goes in the second quadrant. Okay. So like this we can see that we can find all trigonometric ratios. Yes. Now let us go to next one. Yes, it is in the second quadrant. So let's see the next question. Now we have to find the triple of 2a plus 90. 2a plus 90. So it is very interesting. We have to do it in 2 stages. First we have to take the double angle of a, and then we have to take the triple of 90, and then we will add that double angle triple and 90 triple together. Okay. So therefore 2a triple is, we know the formula, x square minus y square, 2xy and r. So 5 12, so 25 square. So 25 minus 144, 2 multiplied by 5 multiplied by 12 and 13 raised to 2. Right. So this was our formula. The formula was x square, 2xy and r square. So according to that formula 25, so we obtained the triple 2a minus 119, 120, 169. Of course, this is minus 119, so cos is negative. So this is not correct. It should be fourth quadrant. Now, second 90 is 011. So therefore 011 is the, we have seen it is a triple of 90 and now we have to add it. So now tell me what is the triple of 2a plus 90. You can type it. So tell me what is, yes, already. So 2a plus 90, so you have to use SAM method because we are doing the addition. Yes, okay. So 0, so this will be minus 120. Minus 119 and 169, right? So this is the triple of 2a plus 90. So we can see that second quadrant is correct. Cos negative and sin positive. Okay, yes. Okay, so now this is the, we can see that it is coming. So let's see. So therefore, minus 120 minus 119, 169. And we can see that it is in the third quadrant because both are negative and only tan is positive, that we know. And therefore, it is in the third quadrant. So this is the way we can decide quadrant. We can find all trigonometric ratios of double angle as well as the quadrant plus double angle together. So the complexity level we can increase as we require, as we want. We can design more complex problem. We can design a show that type of questions. Rather, we can solve the show that type of questions using triple algebra, which is very interesting. And which is very simple also. It turned out to be a simple algebraic problems rather than the trigonometric problems. So now again 3, 4, 5 similar question. Now I am going to wait if any one of you is going to answer. Okay. So 270, first consider triple of 2a. Consider triple of 270. Now you have to use the subtraction and construct the triple of 270 minus 2a. So now I am going to wait till you do it. Then we will see. Okay. So let's find the triple of 270 minus 2a. Oh, already some answers are coming. Okay. So 2a का पहले find out करना है. So 9 minus 16, 24, 25. So I think it is, and 270 we know what is the triple of 270. So let's see. So 0 minus 1 minus 1. Right? So everywhere hypotenuse will be always 1. So 0 minus 1 minus 1 and minus 7, 24, 25. Now we have to do subtraction. So first we have to add. So 0 plus minus 24. So it will become minus 24. Then 7 minus 0, so 7 and 25. So you can see that this is the base, this is the height, and this is the hypotenuse. And therefore base is responsible for cos. So cos is negative. And sine is positive. So therefore it is in the second quadrant. Yes. So sine is positive, so it is in the second quadrant. Right. So this is correct. Okay, so you can find all trigonometric ratios of 270 minus 2a given the one triple of a. Okay, so let's now again the question, find the triple of 105. So how we are going to solve it? Yeah, Shubham, you are correct. Deepika, madam, you are also correct. So most of you are now doing it. So now let us see the triple of 105, how we can split it into two known triples. So how we will split it and then how we can find out. 60 and 45. Yes. So 60 and 45. And we know the triple of 60. So how to construct a triple of 60? Let us see that. So suppose we have, this is 60 degree. And we have constructed it before. This is 30. So this is half. This is root 3 by 2. And this is 1. Multiplying with 2. We get the triple of 60 as 1 root 3 and 2. So 60 will be 1 root 3 and 2. 45, as we know, it is 1, 1 and root 2. And therefore, we can construct 105 using SAM method, addition. So 1 plus, subtraction. So 1 minus root 3, then 1 plus root 3 and 2 root 2. So I know this was quite difficult in 11th standard when we were doing this. When we have to use the compound angle, we have to remember the ratios, we have to substitute it, evaluate it. But it is very easy, and therefore I can see that 105, I can find out all trigonometric ratios when I know this. Okay, I can find sine 105, cos 105, and all trigonometric ratios. So therefore this. Now similarly, next find the triple of 165. So these are the, how to split that. Let us see. So let us see how to split it. So it is twice 60 plus 45. Okay. So now we have to do double angle plus 45. So we can do this way because we know already 60. We have used it. So we know the 60 triple as 1 root 3 2. And therefore if my A is 60 degrees, I can always find double of A as taking the formula x square minus y square 1 minus 3, that is minus 2. Then 2ab, that is 2 root 3, and square of 2, which is 4. So this is the triplet of 120, and the 45 triplet is 1 root 2. And now I just have to add them. So minus 2 plus 2 root 3, then 2 root 3 minus 2. So therefore I can get minus 2 root 3, 2 root 3 minus 2 and 4 root 2. So therefore this is my 165. Now see, with the help of triple, if we can put the value of root 2, we can directly get all trigonometric ratios. So as you can see, I can compose it into I can divide it, I take 2 common, divide everything by 2 and convert it into the complex triples. So this is a way. Now, the next part is half angle triple. Sonia madam, can you please mute? Thank you. So triple of half of A. So X, Y, R. So if I want to do half of triple, it is very simple. The formula is you just add X and hypotenuse R, which is your base, your y will remain as it is, and whatever r you can calculate using, once you get these two, you can automatically calculate r. So we have put it as a dot dot. So that means it can be calculated accordingly. So this is the formula of half angle. And half angles are very, very important in trigonometry, and they are very painful also. So painful to work on. So 4, 3, 5. So if I want to consider half angle, I will just add 4 and 5. So that will become 9, 3, and hypotenuse will be root of 81 plus 9, whatever that is. So therefore root 90. So this will be by the triple of 9, 3 and root 90. This is the automatically I get the triple of half angle. So therefore I can use double angles, I can use half angle, I can use quadrantial angle. And therefore if I divide this 9, 3 and root 90 by common divisor 3, I can split this as 3, 1 and root 10. So therefore this is the way half. Now let us see the half angle triple. See, it is very simple. How you have to do is, I'll just write the formula. If it is x, y and r, what is this? It is just x plus r, y and whatever that hypotenuse is. So using this formula, you can find out the half angle triple. So suppose this is A, B, C, D, E and F. Then half of A, how you will get it? Yeah. So we have seen the formula. Yes. So we have seen the formula x plus r, y and r. So x plus r. So therefore, what is x plus r? 18, 12 and whatever this r is. Then similarly, half of b will be 15 plus 17, 32. Then 8 will be as it is, and whatever this r, root of 32 square plus 8 square. Then half of c will be 8 plus 17. So that will be 25, 15 and whatever that r is. Half d will be 119 plus 169, 288, 120 and that r. Similarly, half e will be minus 4 plus 5. So 1 minus 4 plus 5, 1, 3 and whatever this, that is root of 9 plus 1, so root 10. And half f will be 24 plus 25, 49 minus 7 and accordingly. So this is the way we can obtain half angle. So this is about today's session actually. So this is the way we see 5 ka hoga 1, 3 root 10. Okay, 9, 6. I can see the answers. 9, 6. Yes. So therefore, this you can actually उसमें से common निकाल के you can convert it into compact form. And so you can see that all trigonometric angles can be obtained with the help of, so I'm just stopping the sharing of the screen. And so this is about today's session, that how trigonometry can be simplified with the help of triples. Thank you for listening. And if you have any questions, you can always post it. And I'm very, very glad that very interactive audience I have got here. Students were answering, and thank you very much.
Thank you so much, ma'am. Is there any query? From all participants, is there any query? Sharad ji, is there any query? No. Okay, I think, ma'am, this lecture was wonderful about the triples. About the construction of triples, what is triples means आपने बहुत कुछ बताया, means around आपने बताया addition of triples and how can we subtract both the triples and half of triangle. You were just telling about us half of the triangle and just doubling of the triangle. So I would like to invite Dr. Bhupender Singh sir. He is an associate professor, Department of Mathematics of Meerut College. Sir, we would like to invite you here for concluding the session actually. So, sir, please chair. You are just chair the session.
Respected Madam, myself Dr. Bhupender Singh, and you are Dr. Prajakati Ghokhle from Pune. Your lecture I attended just now about the triples of an angle and half of the angle and twice of the angle, and then after that you told how to find the sum of the triples, and it was a very informative lecture for us, for our audience, and I think the Vedic mathematics, there is no mathematics before the Vedic mathematics. You told some formulas related to half of the angles. I noted down, and I want to learn from you, madam. You just write down an angle A and just write down the triples X, Y, and R. And I think X is a base. And Y is a perpendicular. And after that, R is a height.
Hypotenuse.
Okay. And next one, if you just write down 1 upon half of angle, you just write down X plus R. And then Y is retained as itself. And after that, you just use the radical formula for that. So, as a audience also, I would like to ask a question, madam, here. What is the application of this triplet in real world system? Where we can apply such type of triplets? Can we apply in a defense system where we've targeted a missile to the enemy target? Or any other applications? Madam, I would like to ask if you comfortable.
Yes. Yeah, sure, sir. Thank you for this question, because see, what we have seen is in all our historical literature, all these trigonometry and especially triple trigonometry, most of it is developed on basis on focused on how to understand astronomy. So basically, different position of planets, different angles, then how the angle is or how the relative position of Earth and Sun is moving. So everywhere this half angle is very important to find out the half chord and then finding out the radius of any particular planet. So for all that, actually this angular distance is measured. And even today, it is applicable when we are having a very high dimension telescopes. So when we have this high dimension telescope, they measure this half angle of a certain disk of a planet. And when based on that, you can find out the radius of that planet. Maybe nowadays it is also possible using the extrasolar planets also we can find out how large they are. So I think these applications are very prominent in the field of when we are exploring out of solar, like other than our solar system, other solar system, and how those planets are. Because I am also a student of astronomy. And therefore, it is very amazing that how they are using this high intensity telescope nowadays and the knowledge of trigonometry. And it is not very complicated trigonometry. It is simple trigonometry and simple angle they are using, and the little bit of calculus to actually calculate how much is the size of the planet which is away from millions of light years and it is rotating some other sun. So it is a very important application, and thank you for asking that question.
One more question we have in my mind. You just write down half of an angle. Can we write down the triplet of a 1/3 of an angle in the system?
Yes, it can be. It can be done. Yes, 1/3 of an angle can be also be calculated.
Thank you.
Yes.
Thank you so much. From the
Yes.
audience and from myself, I would like to thank a very beautiful lectures and informative for this sessions. And I think all the participants and the audience will definitely benefit about your lecture. Thank you, madam.
Yes, thank you. Thank you, sir. Yes.
Thank you so much, sir, for coming here. Thank you so much, ma'am.
Thank you. Thank
Nice.
you. Yes.
It was a nice lecture and very informative lecture about the triples. So I think it will be beneficial for the students and teachers also. Thank you so much, ma'am,
Thank
for
you.
just joining our workshop. I would like to tell about tomorrow's session. The first session of tomorrow, that will be the fifth day. First session will be of Naveen Bhargav sir. Second session will be of Dr. Anuradha Gupta ma'am from Delhi University. The third session will be of Uday Kiran sir from Shri Sai Satyashri College, Andhra Pradesh. And these all are the topics which are related to Vedic mathematics, and also these topics are related to ancient Indian mathematics also. So must join tomorrow at the time. So till now, good day. Have a good day. Thank you. Thank you so much.